Welcome to Spring LIB.
This is the answer to Chapter 12, problem number 51 from the Smith Organic Chemistry textbook. And this problem gives us two reactions. So we get a formula for a starting material, we get an oxidative cleavage reaction, and then we get a product. And so we are asked to determine what that starting material looked like. And so I'm going to put my answers in green here. So this first molecule in A, we need to know where it came from. And so the easiest way to do that, since we're dealing with oxidative cleavage reactions, just think about putting these oxygens end to end, and then just joining them together. So making the double bond there between the two carbons that are carbonyls right now. We should replace that with a double bond instead. And so that is going to end up looking like this. So it's going to end up being a six-membered ring with the double bond in the six-membered ring, and then an isobutyl substituent. Okay, and if we wanted to check that, we can calculate the HDI for the formula that we were given. So HDI, remember, is going to be 2 times the number of carbons, so 2 times 10, plus 2, minus the number of hydrogens, so minus 18 here, and then all of that over 2. So 22 minus 18 is going to be 4. 4 over 2 is going to be 2. And so we do indeed have one ring and one double bond. So that satisfies this calculated HDI. And then if you were to count out the carbons and hydrogens, you would see that it fits as well. And so that's our answer for A. So for B, we can do exactly the same thing. So if we imagine, again, linking these oxygen to oxygen and then just replacing the oxygens with a carbon-carbon double bond, what we end up with is fused rings. So this fused rings with the double bond at the bridge between those two rings. And then again, if we wanted to double check this, we could do the HDI. So the HDI here is going to be 2 times 10 plus 2 minus 16, all of that over 2. So this time it's going to equal 3. And we do have 2 rings and 1 pi bond, so for a total of 3. And then again, if we were to count our carbons and hydrogens, they do match this formula that we were given. And so that's the way to approach this problem, and problems like this is just to line these molecules up so that the carbonyl groups are end to end, and then condense them to just a carbon-carbon double bond. And that's the answer to Chapter 12, problem number